Okay, you guys, so since I couldn't be here today, I still wanted to be able to go through your quiz with you and also a review for your three-dimensional molecules. So please get out the polarity molecule quiz that Miss Lauritsen should have handed, or the sub should have handed back to you. If we look at number 1, a lot of you got a +1 on that. That was a 1 point, because what I was looking for was, you could also say that there was a difference in electronegativity, which most of you did, but you have to understand that the difference in electronegativity causes an unequal sharing of electrons. So if you didn't put unequal sharing of electrons, then you didn't get full credit. That one was worth 2 points. So you got to remember, like if we have hydrogen and fluorine here, fluorine has the free electrons around it. These electrons here in the bond are getting pulled towards the fluorine, and so that's why there's a difference in the electronegativity. It's because of the unequal sharing of electrons. So the unequal sharing causes the difference in electronegativity. So you really needed to have both to show me that you truly understood that. Number 2, most of you did well with that. I was looking for the fact that if you have bonds all the way around a structure, these are all polar bonds. We can indicate that with these dipoles, but they cancel each other out, and that's why it ends up being nonpolar. So that's what I was looking for, the canceling part, and most of you did a nice job with that. On the drawings, few people did water incorrectly and said this was nonpolar. Now you guys, we've talked about this a lot. These are free electrons up here. Oxygen is more electronegative than hydrogen, and so this has to be a polar molecule. We've talked about that for 2 chapters. We know that water is polar. This is why. More electronegative at the top here, less electronegative here at the bottom. A couple people drew carbon dioxide here as a bent molecule that cannot be bent. We've talked about how double bonds make it straight, so you had to have your carbon, your double bond on each side, straight, and then your free electrons on your oxygen. Several people forgot free electrons. I'm going to make you guys going back to circling if you don't remember those free electrons. Same with ammonia here. A lot of people forgot these free electrons. We need to have those dipoles on every single one of these bonds, and this is also polar. This one over here was nonpolar because if you split it in half, it's equal on each side. But if you draw it as a bent molecule like this, it is not nonpolar, so that's why this one cannot be correct. Those were the most common mistakes I saw. Few people still forgot math. You missed a point for everyone if you didn't do that. So retakes will be the rest of this week and have to be done by Friday. So again, you'll just have to get a pass from me when I get back on Wednesday. Now go ahead and get out your more modeling, molecular molecules part 3, the one that we worked on in class. For a couple days, we're going to go through all the shapes here. What I did on this sheet is, if it was completed, you got 5 points because you did your homework and you had it done. You used your time in class and you had it done. If you didn't have it completed, you didn't get points at all. So it was kind of like an extra credit thing. Whatever you do, is make sure you follow along with me right now, because you're going to need to make sure you have these shapes correct, because this is going to be your assessment later on in the week. You're going to be drawing a 3-dimensional model and writing down all the different shapes. So make sure you write this in on this sheet so that you have this to study with. The first 2 we already did, so we're going to move down to the 2 isomers. One is right here, over here, and then the other one is over here. So what you want to do is, this is our first carbon. You want to look at this first carbon and see that it has 1, 2, 3, 4 bonds around it, but really 3 different areas. So when you look at 3 different areas of bonding, that is going to be a trigonal planar. If I can spell it right, trigonal planar shape, because there's 3 areas of bonding, or 3 things around it. When you move to the next carbon, exactly the same. A double bond here, single bond here, single bond here. So C2 is also going to be the same shape. We also have to put the shape for oxygen. So oxygen has 2 free pairs of electrons and 2 bonds. So if you look at your shape sheet, the geometry, the molecular geometry, is going to be bent. For oxygen, it is a bent structure because we've got 2 bonds and 2 pairs of free electrons. That was the first isomer. The second isomer here, and it didn't matter where you had which, you could just have them both places. Here you can see your carbon has 4 bonds. First carbon, shape is going to be tetrahedral. Second carbon, 1, 2, 3 bonding areas again. So this one is going to go back and be that trigonal planar. So make sure you have those shapes correct. Just those two this time. This is really linear from the oxygen to the carbon. You could put that, but there's really no need to. Now if you go ahead and flip to the back, the top one, your CCl4, I didn't draw here because that's just a basic tetrahedral. Honestly, let's go back and look at our 3 dimensions. I'm sorry, I forgot to do that on these. We go back here. For this first isomer, we're going to have two of these hydrogens came forward, so you should have a wedge on this one here, and then we should also have a wedge on this one here, because those both came forward to you. So make sure you have your 3-dimensional model like that. Then on your other isomer, the only one that wasn't in the same plane is this hydrogen, and that should have been wedged towards you also. Okay. Now go ahead and flip over to the back. I'll try this again. This one here was probably the most difficult one to do, the one with the nitrogen in it, the second one down. Again, the first one I said is just tetrahedral, so that was a pretty basic one that we've gone over several times. Make sure you have it drawn this way. Your nitrogen needed 3 bonds, and then it has the 2 free electrons here. Carbon has 4 bonds here, carbon has 4 bonds here, and then your oxygen has 2 bonds here. What you wanted to do this one for 3 dimensions is this hydrogen should be wedged forward. Everything else was in the same plane. And then if we look at shapes, we're going to want to look at our nitrogen. 3 bonds and a pair of free electrons. So for our nitrogen, this is trigonal pyramidal. For your carbon, 4 bonds on this one, so this is our first carbon. Carbon 1 is going to be tetrahedral. Second carbon, there's only 3 bonding areas around it, so carbon 2 is going to be trigonal planar. 1, 2, 3. And then your oxygen here again, 2 free pairs of electrons, 2 bonds, so your oxygen is going to be bent. So you need to have all 4 of those shapes, okay, if you didn't. Then we've go on to hexane. Hexane is just a straight chain of carbons. They are zigzag when you do them in 3 dimensions, and you should have one of these wedged and one of them dashed for each one of your carbons. Okay, so make sure when you do 3 dimensions you did that. If you had them both down here, that's perfectly fine too. Like if you dash the hydrogen here, that would count as this one, and not have that one. That would also work perfectly fine. So you could do it either way, whichever made more sense to you. So like that or like this. Just make sure you have one wedged and one dotted for each one, and then your end hydrogens are in the same plane. Now with this one, if you look, every single carbon has 4 bonds around it, no matter how you drew it. Okay, so 1, 2, 3, 4, 1, 2, 3, 4. So all carbons are going to be tetrahedral in this one. Now a lot of you did not do cyclohexane correct. Cyclo means circular, so it has to be drawn in this circle. Okay, so again, if you didn't have it that way, add this, and then you had 2 hydrogens on every single one of your carbon. When you do this one 3-dimensional, one carbon is forward, and then the other one should be dashed going backwards all the way around. So 1 hydrogen wedged and 1 dashed for every single carbon all the way around. This shape is just circular or cyclo because it's in a circle. Okay, so that's one that's very different. We won't have this on any assessments, but I just wanted you guys to be able to see that that can happen. So that is what you're going to see on your assessment. I believe I have it set for Wednesday to do. It might be Friday. I'll have to look on Moodle and let you know for sure. I'll let the sub know. But these are the things that you're going to have to understand to do your shapes and your 3 dimensions for that. Now what you guys are going to do is just work on a practice sheet for the rest of the hour, and then completing your homework for tomorrow.